Hello everyone, welcome to lecture 9 of CRN 708, and in this week we shall be looking at systems development and project management. The lecture is divided into two sections, and in section 9.1 we shall be exploring developing enterprise applications with the introduction of system development lifecycle, the different software development methodologies, agile software development methodologies, and service-oriented architectures. In section 9.2, we will explore project management, and we shall look at the delivering of successful projects, the elements of project planning, primary project planning diagrams, and outsourcing projects. Section 9.1, developing enterprise applications. The learning outcomes for section 9.1 include describe the 7 phases of the systems development lifecycle, summarize the different software development methodologies, and 3, explain why a company would implement a service-oriented architecture. The system development lifecycle. Organizations must learn how to build and implement disruptive technologies such as software for wireless devices to remain competitive. Software that is built correctly can support agile organizations and can transform as the organization and its business transforms. Software that effectively meets employee needs will help an organization become more productive and enhance decision-making. Software that does not meet employee needs may have a damaging effect on productivity and can even cause a business to fail. A software introduced to an organization needs to cater for the processes and the people needs, and not the other way around. Therefore, software development cycle plays a very key role. The systems development lifecycle. As organizations' reliance on software grows, so do the business-related consequences of software successes and failures, including increase or decrease in revenue. For example, Nike's poorly designed supply chain management software that delayed orders, increased excess inventories, and caused third quarter earnings to fall 24% below expectations. Repair or damage to brand reputation. H&R blocked customers were furious when the company accidentally posted passwords and social security numbers to its website. Prevent or incur liabilities. Foxmeyer sued SAP for $500 million for an ERP failure. Increase or decrease productivity. Defective software accounts for 45% of computer downtime and costs US businesses close to about $100 billion per year. The system development lifecycle. In software engineering or systems engineering, information systems and software engineering, the software development lifecycle, also referred to as application development lifecycle, is a process for planning, creating, testing, and deploying an information system. The overall process for developing information systems from planning and analysis to implementation and maintenance. The phases in the SDLC include planning, analysis, design, development, testing, implementation, and maintenance. Let's broadly have a look at these phases. First of all, we should look at the planning phase. It establishes a high-level plan of the intended project and determines project goals. The planning phase of the SDLC is also when the project plan is developed that identifies, prioritizes and assigns the tasks and resources to build the structure of a project. With that said, this step culminates in a detailed project plan. The system analysis phase involves analyzing end-user business requirements and refining project goals into defined functions and operations of the intended system. The analysis stage includes gathering all the specific details required for a new system, as well as determining the first ideas for prototypes. Developer may define any prototype system requirements and evaluate alternatives to existing prototypes. System design phase. It establishes the descriptions of the desired features and operations of the system, including screen layouts, business rules, process diagrams, pseudocode, and other documentation. The design phase is a stage where software developers define the technical details of the product. Depending on the project, these details can include screen designs, databases, sketches, system interfaces, and prototypes. Development phase involves taking all of the detailed documents from the design phase and transforming them into the actual system. The system development lifecycle, also referred to as application development lifecycle, and in the process of development phase ends up developing the software in a physical design. Testing phase involves bringing all the project pieces together into a special testing environment to eliminate errors and bugs and verify that the system meets all of the business requirements defined in the analysis phase. The testing phase of the software development lifecycle is where you focus on investigation and discovery. During the testing phase, developers find out whether their code and programming work according to customer requirements. Implementation phase involves placing the system into production so users can begin to perform actual business operations with it. This phase is initiated after the system has been tested and accepted by the user. In this phase, the system is installed to support the intended business functions. The system performance is compared to performance objectives established during the planning phase. In the system implementation phase, there are 4 common types of implementation methods. First one is parallel implementation. Now, parallel implementation uses both the legacy system and new system until all users verify that the new system functions correctly. Parallel adoption is a method of hardware or software migration that involves using the existing and the new systems simultaneously until the implementation is judged to be complete and satisfactory. During the transition, workers work with both systems as they gradually learn the new software. Plunge implementation. Plunge converts the whole organization to the complete new system at one time, discards the legacy system, and immediately migrates all users to the new system. Pilot implementation assigns a small group of people to use the new system until it is verified that it works correctly. Then the remaining users migrate to the new system. A pilot implementation allows an organization to validate its approach for full application deployment. Executing an application pilot can uncover operability issues associated with production-like conditions and provide an opportunity to address these issues before full application rolls out. Phase implementation installs the new system in phases, for example, by department, until it is verified that it works correctly. Phase implementation is a method of system changeover from an existing system to a new one that takes place in stages. As an example, think of a supermarket. In this supermarket, the checkout system is being upgraded to a newer version. And the final and the 7th phase of the SDLC is maintenance phase. It involves performing changes, corrections, additions, and upgrades to ensure the system continues to meet its business goals. System maintenance is an umbrella term that encompasses various forms of computer maintenance needed to keep a system running. Software development methodologies. There are a number of different software development methodologies, including waterfall, agile, RAD, XP or extreme programming, RUP or additional unified process, and Scrum. Let's have a look at these in more detail in the next set of slides. Waterfall methodology, a sequence of phases in which the output of each phase becomes the input of the next. Waterfall methodology is a sequential activity-based process in which each phase in the SDLC is performed sequentially, that is one after the other, from planning to the implementation and maintenance phases. The waterfall methodology is one of the oldest software methods and has been around for over 30 years. The success rate of software development projects that follow this approach is about only 10%, or 1 in every 10 projects. The biggest problem with the waterfall model is that it assumes users can specify all business requirements in advance. In the waterfall methodology, the following phases occur starting from top and then flowing down. Each of these steps are performed sequentially, that is, one after the other. And it starts with planning and moves down to analysis, then to design, then to develop, then to testing, implementation, and finally maintenance. Agile methodology. Agile methodology is a form of extreme programming, aims for customer satisfaction through early and continuous delivery of useful software components. It has an iterative development approach that consists of a series of tiny projects. Agile methodology aims for customer satisfaction through early and continuous delivery of useful software components developed by an iterative process using the bare minimum requirements. Rapid application development methodology. RAD is a more popular route for system development projects. The fundamentals of RAD include focus initially on creating a prototype that looks like and acts like the desired system. A prototype is a smaller scale representation or working model of the user's requirement or proposed design for an information system. Moreover, the other fundamentals of RAD include actively involve system users in the analysis, design, and the development phases. Accelerate collecting the business requirements through an interactive and iterative construction approach. Extreme programming methodology, or XP. XP breaks a project into tiny phases, and developers cannot continue on to the next phase until the first phase is completed. The primary difference between waterfall and XP methodologies is that XP divides its phases into iterations and with user feedback. Rational unified process methodology. Now, rational unified process provides a framework for breaking down the development into 4 gates, and these gates include inception, elaborate, construction, and transit. Because RUP is an iterative methodology, the users can reject the product and force the developers to go back to gate 1. Approximately 500,000 developers have used RUP in the software projects of varying sizes in the 20 years it's been available, according to IBM. RUP helps developers avoid reinventing the wheel and focusing on rapidly adding or removing reusable chunks of processes addressing common problems. Let's discuss the 4 gates. So gate 1 is inception. The primary objective is to scope the system adequately as a basis for validating initial costs and budget. In this phase, the business case, which includes business context, success factors, and a financial forecast, is established. Gate 2 is elaboration. The primary objective is to mitigate the key risk items identified by analysis up to the end of this phase. The elaboration phase is where the project starts to take place. In this phase, the problem domain analysis is made and the architecture of the project gets its basic form. Gate 3, construction. The primary objective is to build the software system. In this phase, the main focus is on the development of components and other features of the system. This is the phase when the bulk of coding takes place. In larger projects, several construction iterations may be developed in an effort to divide the use cases into manageable segments to produce demonstrable prototypes. Gate 4, transition. The primary objective is to transit the system from development into production, making it available to and understood by the end user. The activities of this phase include training the end users and the maintenance and beta testing the system to validate it against the end user's expectations. The system also goes through an evaluation phase. Any developer which is not producing the required work is replaced or removed. The product is also checked against the quality level set in the inception phase. Scrum methodology. Scrum's insistence on delivering complete increments of business value in 30 days learning cycles helped the teams land rapidly. It forced teams to test and integrate experiments and encourage them to release them into production. It is a different feel to the way programming happens. Instead of mindlessly cracking out code, the process is one of team dialogues, negotiation around priorities and time and talents. The entire company commits to a 30-day sprint and delivery of finished tested software. Maybe it is just one specific piece of functionality, but it's the real thing, including delivery and client review against needs and requirements. Those needs and requirements, by the way, change. That is the strength we saw in the Scrum process. So overall, to summarize the Scrum process, it uses a small team to produce more pieces of deliverable software using sprints or 30-day intervals to achieve an appointed goal. Under this methodology, each day ends or begins with a stand-up meeting to monitor and control the development effort. Developing a service-oriented architecture. Service-oriented architecture, or SOAR, is a business-driven enterprise architecture that supports integrating a business as linked, repeatable activities, tasks, or services. Service-oriented architecture helps companies become more agile by aligning business needs and the IT capabilities that support these needs. Business drivers requirements for IT. SOAR enables the IT environment to respond to these requirements effectively and efficiently. Now, SOAR generally includes three things: service, loose coupling, and interoperability. First of all, let's have a look at service. Service may be any business task. Interoperability is the capability of two or more computer systems to share data and resources, even though they are made by different manufacturers. A web service is an open standards way of supporting interoperability. Extensible markup language, or XML, is a markup language for documents containing structured information that also helps support interoperability. Loose coupling is the capability of services to be joined on demand to create composite services or disassembled just as easily into their functional components. Loose coupling is a way of ensuring that the technical details such as language, platform, and so on are decoupled from the service. Section 9.2, Project Management. This section takes a look at extending an organization through supply chain management and discusses the reasons for supply chain management's explosive growth, using supply chain management to enhance decision-making and supply chain management success factors. Traditional supply chain management thinking involved, I buy from my suppliers, I sell to my customers. Today, organizations are quickly realizing the tremendous value they can gain from having visibility through their supply chain, knowing immediately what is transacting at the customer end of the supply chain, instead for waiting days or weeks for this information to flow upstream, allows the organization to react immediately. The learning outcomes for this section includes explain project management and the primary reasons project fail, identify the project planning diagrams, identify the 3 different types of outsourcing along with their benefits and challenges. Using project management to deliver successful projects. Primary reasons for project failure include unclear or missing business requirements. This is where during the planning phase of the SDLC, the requirements are not clearly defined. Skipping SDLC phases. Skipping of SDLC phases can lead to a drawback to the software development process. Failure to manage project scope. Project scope is generally defined by scope creep and feature creep. Scope creep occurs when the scope increases. Feature creep occurs when extra features are added to the planned project. Failure to manage project plan and changing technology. Using project management to deliver successful projects. Tangible benefits are those that are quantifiable and measurable, sometimes called hard savings. In other words, there are improvement project benefits that have some specific dollar value, number of labor hours, or other specific metric that can be determined to have been achieved through the project. Tangible benefits may include decreased expenses, decreased processing errors, decreased response time, increased quantity of sales, increased quality. On the other hand, intangible benefit is a more subjective benefit that you can't actually touch and is difficult to measure in terms of dollar value. This is in contrast to tangible benefits, which are those assets that can be measured like a cost break on a new office computers. Intangible benefits may include improved decision-making, improved community service, improved goodwill, and improved employee morale. Using project management to deliver successful projects continued. With project management and planning a project for a software development, generally feasibility studies need to be carried out. Feasibility means the state or degree of being easily and conveniently done. Some common feasibility studies may include economic feasibility. The purpose of an economic feasibility study is to demonstrate the net benefit of a proposed project for accepting or disbursing electronic funds or benefits, taking into consideration the benefits and the costs to the agency, other state agencies, and the general public as a whole. The next feasibility study is operational feasibility. Operational feasibility is the measure of how well a proposed system solves the problems, takes advantages of the opportunities defined during scope definition, and how it satisfies the requirements identified in the requirements analysis phase of system development. Moreover, it measures how well a solution meets the identified system requirements to solve the problems and take advantage of opportunities. Schedule feasibility. It measures the time frame to ensure that the project must be completed on time. Scheduled feasibility is the degree to which a deadline for a strategy, plan, project, or process is realistic and achievable. Technical feasibility. It measures the practicality of a technical solution and the availability of technical resources and expertise. Technical feasibility is a process of figuring out how you're going to produce your product or service to determine whether it's possible for your company. Before launching your offerings, you must plan every part of your operations from first sourcing your production materials all the way to tracking your sales. Political feasibility measures how well the solution will be accepted in a given organization. Political feasibility is a measure of how well a solution to a policy problem will be accepted by a set of decision makers and the general public. For a policy to be enacted and implemented, it must be politically acceptable or feasible. Legal feasibility measures how well a solution can be implemented within existing legal and contractual obligations. Legal feasibility determines whether the proposed system conflicts with legal requirements. Example, data processing system must comply with the local data protection regulations and if the proposed venture is acceptable in accordance to the law of the land. It is often paramount that errors can be detected when working with the system development lifecycle. However, the later in the SDLC an error is found, the more expensive it is to be fixed. Errors found during the testing or implementation phase is going to cost the organization an enormous amount to fix because it has to change the actual system. Find errors early and as early as possible because when found in the later stages of the SDLC, it is more expensive to get it fixed, as many of the processes may need to be redone, or the project may be scrapped off if it's too burdensome, time-consuming, expensive, and costly to fix these errors. The consequences of failed project include brand damage, lost goodwill, dissolution of partners, lost investment opportunities, low morale. Analysts predict investment in IT projects worldwide are over $1 trillion. This is a staggering amount, and even more staggering is that 70% of it will be merely washed down the drain as a result of failed projects. In addition to the lost earnings, companies like Nestle to Nike have experienced additional consequences of failed projects, like a damaged brand, lost goodwill, dissolution of partners, lost investment opportunities, and effects of low morale. According to the Standish Group, just 29% of IT projects were completed on time, within budget, and with features and functions originally specified by the customer to deliver business value. With so many skilled and knowledgeable IT professionals at the helm of IT projects, how can this happen? Well, everyday organizations adopt projects and do not align the mission-critical initiatives. They overcommit financial and human capital. They sign off on low-value projects that consume valuable and scarce resources, and they agree to support projects that are poorly defined from requirements to planning. Project Management Institute, PMI. PMI stands for Project Management Institute. It develops procedures and concepts necessary to support the profession of project management. PMI is a non-profit making organization and it builds a professional membership for project managers and program managers. PMI started in the year 1969 and now has a membership of more than 2.9 million professionals worldwide. The three focus areas include ethics, standards, and accreditation. The three constraints of project management: time, resources, and scope are the three constraints of a project. All these three variables are interdependent on one another. You cannot change one without changing the other. For example, decreasing a project's time frame means either increasing the cost of the project or decreasing the scope of the project to meet the new deadline. Increasing a project's scope means either increasing the project's time frame or increasing the project's cost, or both, to meet the increased scope changes. Project management is a science of making trade-offs among time, resources or costs, and scope. Project management offers a strategic framework for coordinating the numerous activities associated with organizational projects. A project is a temporary activity undertaken to create a unique product or service. Now, why is a project temporary? A project is temporary because it has a start and an end date. Remember that a project is not a process. Project management: the application of knowledge, skills, tools, and techniques to project activities to meet project requirements. A project manager is an individual who is an expert in project planning and management, defines and develops the project plan, and tracks the plan to ensure that the project is completed on time and on budget. Project deliverable is any measurable, tangible, verifiable outcome or result or item that is produced to complete a project or part of a project. A project milestone represents key dates when a certain group of activities must be performed. Project Management Office, an internal department that oversees all organizational projects. What is the relationship between project deliverables, project milestones, and project managers? Well, project deliverables are usually project milestones. Project milestones and project deliverables are defined and monitored by the project manager. And the Project Management Office looks after project deliverables, project milestones, and the work of all that the project manager does. Project participants. Project stakeholder. A project stakeholder, it may be individuals or organizations that hold stake with the business. In other words, they are actively involved in the project or whose interests might be affected as a result of project execution or completion. An executive sponsor is a person or a group who provides financial resources for the project. However, research has shown that the leadership strength of the executive sponsor has more to do with the success or failure of a project than any other critical success factor. In fact, the executive sponsor should be accountable to the project team for much more than financial backing. The executive sponsor communicates up the chain on behalf of the project. He or she supports the project manager by championing the project to others, sharing the vision and benefit of the successfully completed project. And the executive sponsor demonstrates the commitment and accountability necessary to survive a project. If a team has a hands-off sponsor who merely reviews invoices and inquiries as to the status of a project, then the project surely is in trouble from start. Primary project planning diagrams. No one would think of building an office complex by training loose 100 different construction teams to build 100 different rooms with no single blueprint or agreed upon vision of the completed structure. Yet, this is precisely the situation in which many large organizations find themselves when managing information technology projects. Organizations routinely overschedule their resources, develop redundant projects, and damage profitability by investing in non-strategic efforts that do not contribute to the organization's bottom line. Project management offers a strategic framework for coordinating the numerous activities associated with organizational charts. Now, SMART criteria are useful reminders on how to ensure that the project has created understandable and measurable objectives. SMART is basically a collection of abbreviated terms for specific, measurable, agreed upon, realistic, and time frame. A project plan should be prepared by the team rather than by the individual project manager. How would a project team feel if a project manager handed them a plan? Would they work hard to meet the deadlines? Probably not, because the timeframes required to finish the task were forced upon them. They did not participate in the initial estimates and do not feel any ownership on the project. How would they feel about a project plan that they created along with the project manager? Would they work hard to meet the deadline? Probably yes, because they define the timeframes they require to finish the tasks. A project plan is a formal approved document that manages and controls project execution. A well-defined project plan should be easy to understand and read, communicated to all key participants, appropriate to the project size, complexity, and criticality, prepared by the team rather than the individual project manager. Some primary project planning diagrams include, we will be discussing two of them in this slide, and the first one is PERT chart. The abbreviation PERT stands for Program Evaluation and Review Technique. It is a graphical network model that depicts a project's tasks and the relationship between those tasks. Generally, there are two elements found in a PERT chart: dependencies and critical paths. Dependency is a logical relationship between the project tasks or between a project task and a milestone. Critical path is a path from the start to the finish that passes through all the tasks that are critical to completing the project in the shortest amount of time. The next diagram is a Gantt chart. A Gantt chart is a simple bar chart that depicts project tasks against a criteria. Refer to the diagram. The diagram demonstrates or illustrates a PERT chart. The boxes in red denote the critical path. Why is a critical path important? A critical path is important because it informs a project manager of the shortest time frame the project could possibly be completed in the project. A project manager can, of course, bring enormous benefits to an organization, such as reduced project expense, high company morale, and quicker time to market. A competent project manager sets the correct expectations early in the project with achievable milestones. And a PERT chart with the use of a critical path enables a project manager to do so and achieve this target. This is a Gantt chart that displays simple start and finish dates and resource names. A Gantt chart is one of the most common tools used by the project manager. Microsoft Project offers many additional tracking components such as actual start date, budget, and % complete. When reviewing the Gantt chart, you can always point out 3 independent project management tasks, and these may include resources, time frame, scope, or tasks. Outsourcing projects. Now, outsourcing is an agreement in which a company hires another company to be responsible for a planned or existing activity that is or could be done internally, and sometimes involves transferring employees and assets from one firm to another. The two main types of outsourcing includes onshore outsourcing and offshore outsourcing. Onshore outsourcing is hiring another company within the same country. Offshore outsourcing is hiring another company outside the country. Insourcing or in-house development. It uses the professional expertise within an organization to develop and maintain its information technology system. This is where resources such as hardware, software, and expertise may be hired by the organization to develop this system in-house. Factors deriving outsourcing. Core competencies. Many companies have recently begun to consider outsourcing as a means to fuel revenue growth rather than just a cost-cutting measure. Outsourcing enables an organization to maintain an up-to-date technology infrastructure while freeing it to focus on revenue growth goals by reinvesting cash and human capital in areas offering the greatest return on investment. Financial savings. It is typically cheaper to hire workers in China and India than similar workers in the United States or even in UK. Technology is advancing at such an accelerated rate that companies often lack the resources, workforce, or expertise to keep up. It is close to impossible for an IT department to maintain a best-of-breed status, especially for small and medium-sized enterprises where cost is a critical factor. Rapid growth. A company's sustainability depends on both speed to market and ability to react quickly to changes in market conditions. By taking advantage of outsourcing, an organization is able to acquire best practices, process expertise. This facilitates the design, building, training, and deployment of business processes or functions. Industry changes is another factor. High levels of reorganization across industries have increased demand for outsourcing to better focus on core competencies. The significant increase in merger and acquisition activity created a sudden need to integrate multiple core and non-core business functions into one business, while the deregulation of utilities and telecom industries created a need to ensure compliance with government rules and regulations. Companies in either situation turned to outsourcing so they could better focus on industry at hand. The next factor is the internet and globalization. The pervasive nature of the internet as an effective sales channel has allowed clients to become more comfortable with outsourcing. Barriers to entry, such as lack of capital, are dramatically reduced in the world of e-business due to the internet. New competitors enter the market daily. As markets open worldwide, competitions heat up. Companies may engage in outsourcing providers to international service deliveries, which is also known as globalization. Types of outsourcing include onshore, nearshore, and offshore outsourcing. Onshore outsourcing is engaging another company within the same country for the service. Nearshore outsourcing is contracting an outsourcing arrangement with a company in a nearby country. Offshore outsourcing uses using organizations for developing countries to write codes and develop systems. Some common benefits of outsourcing may include increased quality and efficiency of a process, service, or function, reduce operating expenses, resources focus on core profit generating competencies, reduce exposure to risks involved with large capital investments, access to outsourcing service providers, economies of scale, access to outsourcing service providers' expertise and best-in-class practices, access to advanced technology, increased flexibility with the ability to respond quickly to changing market demands, no costly outlay of capital funds, reduced headcount and associated overhead costs expenses, and reduced frustration and expense related to hiring and retaining employees in an exceptionally tight job market. And finally, reduce time to market for service products and services. Outsourcing challenges. Outsourcing challenges include length of contract. Most outsourcing contracts span several years and cause issues. This may be in terms of difficulties in getting out of a contract, problems in foreseeing future needs, and problems in reforming an internal IT department after the contract is finished. Competitive edge. Effective and innovative use of IT can be lost when using an outsourcing service provider. Loss of confidentiality. Confidential information might be breached by an outsourcing service provider, especially one that provides services to competitors. And moreover, we can also say scope definition. Scope creep is paramount with outsourcing agreements. And this finishes our lecture 9 for CRN 708. Thank you for listening, everyone. Goodbye.